Oh, there we go. Okay, so thank you so much, everyone, for turning out tonight. For tonight's SYB webinar, the first of 2022, the hazard in touching grounded objects and what you can do about it. Quick reminder, as you're watching the presentation, you may have questions. When you do, please type them into the Q&A pod. At the bottom of your screen, there should be a little button that says Q&A. Type your questions in there. If you type them into the chat pod, they'll probably be lost by the time we get to that part of the session. So very briefly, today's outline. We'll start with a brief intro of myself. That'll be very, very quick. Then we'll get into the main learning. That'll take about 25 to 30 minutes. And I will present information on the hazard with grounding. And then I will bring in our special guest tonight, Andrew McAfee, to talk about the way to ground healthier. Then I'll give you all of you here live in attendance tonight, a special offer, and then we will have a Q&A session. So very briefly about me, for those of you who don't know, my name is Blank. I'm the CEO of Shield Your Body and the host of the Healthier Tech podcast. Formerly served on the faculty of the University of Southern California, Viterbi School of Engineering, and along with my father, Dr. Martin Blank, co-authored Overpowered on the science of EMF health effects. And this all follows a 20-year career in software engineering. So to kick things off tonight, I wanted to start with a picture. And this is a photo of a product that SYB produced in 2017, and it is a grounding yoga mat. And wait, I hear you all saying, I didn't realize SYB released a grounding yoga mat. And that's because we didn't, and we don't. See, right before launch, after we had everything done, even as you see this photo shoot, I learned of some potential questions around possible side effects of grounding. So I pulled the product from the market. Fast forward a couple of years, now it's in this photo, it's 2020. And what you see there on the left is my SYB bed canopy. And what you see on the right is a feature I did not include in the bed canopy, right? That is a grounding snap. And a lot of EMF protection canopies come with this feature. In contrast, I made the intentional decision not to include this feature on my canopies. Why? Because of the same concerns I just told you about. I thought including this feature would make customers think that they needed to ground their canopy, and I didn't want them to think that. If customers contact my support team, we explain this, and then we also explain how they can ground their canopies if they wish to, but we did not include this feature. So the question is why? What was I so concerned about when it comes to grounding? Well, that's what we're going to talk about today. Because at the time I made those product decisions, I didn't fully understand all of the issues involved. Not until I met today's guest, Andrew McAfee, who is a real expert in this stuff. And what happened was Kathy Cook, SYB's in-house EMF specialist, who many of you know, she was aware of my concerns about these products. And then one day she and I are talking and she tells me, there's this guy you should talk to, Andrew McAfee. And that was 15 months ago. And here we are today. But let me step back a moment. In some ways, grounding, also called earthing, is a simple topic. The whole point is to put your body in direct contact with the Earth's surface. Walk barefoot on park grass, on beach sand. Doing this helps you discharge positive ionization that you accumulate from all your EMF exposure in modern life. And it enables you to absorb the Earth's own natural electromagnetic field, the Schumann resonance. And there are a lot of benefits to grounding. You will feel less stressed after just a few minutes. And grounding in a safe area also neutralizes free radicals in our bodies and reduces inflammation. But a lot of us can't ground into nature, at least not as much as we would like to. So we buy grounding products like grounding mats or grounding sheets. And even those of us who don't own or use any grounding or earthing products actually do still use grounding. Because any product that we own that has a 3-prong plug, that third prong is the ground plug. It performs grounding, not for your body, but for your electronics and your devices and your appliances, which is intended to make the electrical wiring of our various products safer. So even if you don't think you use grounding, you do. But grounding has some risks you might not know about. Those risks include contact current, dirty electricity, and electric fields. Now, I know some of you may not be aware of all of these terms. particularly the first one, contact current. So let me try to explain them for you one at a time. And we'll start with contact current. So what is contact current? Contact, also sometimes called touch current, are electrical currents we are exposed to when we touch certain appliances and devices. And it turns out that we are being exposed to this force all the time. Again, whenever we touch anything associated with our home grounding system, that's called contact current. Where does it come from? Well, here on this slide is one example, right? Many appliances like dryers and ranges come from the factory with the neutral bonded to the appliance frame. And that's a big mistake. And it's a mistake that most manufacturers and electricians don't even care about. They don't even realize it's a mistake. There are many more mistakes made in outlets and subpanels that put current onto the grounding system. And Andrew, our guest speaker, will talk more about this later in the presentation. So we're all used to signs like beware high voltage, warning high voltage. We're all used to worrying about voltage. But while everyone has been focused on protecting against voltage, it is current that kills. And we all know this. It's how the electric chair works. Even the US government says current causes cancer, and it's super low levels, lower than what you get when you touch almost any grounded appliance or grounding product. So we are being exposed to harmful current all the time. Why is current so harmful? Well, to understand what current is, imagine how much energy it would take to rip an electron off of an atom, because that's what the flow of current is. It is the flow of electrons. So here we see a video demonstrating this, right? Where three cells and the electrons are jumping from one to the other. That is the flow of current. And you see that it's ripping electrons from one cell and sending them to another. And when electricity flows through you, that's taking electrons from cells and ripping them out. Now, many of us are aware of the term ionizing radiation. Those are the forms of EMF that have so much energy that they rip electrons from your cells. These are forms of EMF called X-rays and gamma rays, and everyone acknowledges these are super harmful, even in incredibly low doses, right? That's why whenever you get a dental X-ray, they cover you in a lead jacket and the technician literally leaves the room. That is how harmful these are. And ionizing radiation is considered to be so harmful, even in low doses, because it is ripping electrons from your cells. And that is the same thing that current, the flow of current through your body, does. So how much contact current is harmful? Now, that's a very good question. And to help answer that, we're going to look at this report. In the early 1990s, the US Congress wanted to better understand the source of childhood leukemia. So they funded the National Institute of Environmental Health Sciences, right? That's a division of the National Institutes of Health, or NIH, and they funded them to study that question. And the very, very, very long report that they produced had one very important number. And that number is 1 millivolt per meter, right? So the government here is saying that there's a threshold of harm. There is a threshold after which you start to see incidents of childhood leukemia. But the value is unintelligible, not just to you and me, but actually to people who really know this stuff. It is hard to understand what 1 millivolt per meter means. So fortunately, the Electrical Power Research Institute, which is formed by and for the power companies in the 1970s, did the research and experimentation and published their report on what 1 millivolt per meter meant in real world applications. And keep in mind, EPRI is an industry group. It's not like it's a health advocacy group. This is the definition of big power. So what did EPRI conclude the 1 millivolt per meter number meant? 1 microamp. Okay, so how small is a microamp? Well, we're all familiar, or many of us are familiar with the term amp, which is short for ampere. We see that a lot when it comes to electrical implementations. So we're all familiar with the term of an ampere, What is a microamp? Well, it's 1/1,000,000th of an amp, right? So let's pretend a microamp is a dollar bill. How many dollar bills would it take to create a single amp? 1,000,000. So if we think of an amp like $1 million, that helps show just how small a single microamp is. That is the threshold of harm. It is so low. When are you exposed to it? Well, all of the time. And to help demonstrate this, I'm going to show this video that Andrew recorded. And it shows how much current there is on our grounding systems in our home and in the electrical grid in general. Okay, so I'm just trying to stop a freeze frame on the actual display. There. Okay. So here we see 8.9. This is microamps, not milliamps. So that is 8,900 times greater than the threshold of harm. And that is, Andrew is measuring this.
Milliamps,
yep.
Not microamps.
Right. Oh, sorry. Thank you. It's 8.9 milliamps, not microamps. So that's 8,900 times greater than the threshold of harm. And that was on, I believe, his washing machine. And if we go a little further, now he's connecting two devices and we see 13 milliamps. So that is 13,000 times greater. And that was when touching both the stove and the dishwasher at the same time. That is 13,000 times greater than the threshold of harm, right? 13,000 times greater than what was found to have been associated with carcinogenic agents. So we regularly experience levels in excess of 1 microamp just from touching grounded appliances and devices. And that includes when we use grounding products. Next up, we have dirty electricity. Now, that's a term that many people know, but even so, a lot of people don't really know what it is. And we're not going to go into detail here, but I will try to kind of summarize and explain that. See, you see this nice, clean, red wave here, right? That's what electricity is supposed to look like when it gets delivered from the power station. The term dirty electricity refers to variations. These are spikes and surges in the voltage and frequency. And these come from all the stuff that we have plugged in to the grid, particularly things with motors like blenders and things with power inverters like cell phone chargers, right? But all this stuff plugged into the grid, right, turns this nice, clean electricity into dirty electricity, which then flows through all of our electrical wiring. Now, dirty electricity is a big topic with a lot of information, and we don't have time to get into all of it here today. So if you're interested in learning more about where it comes from, just visit the link you see here on the screen. That's shieldyourbody.com/dirty-electricity. We have a lot of information up there on this for us. Now, what does dirty electricity do to us? Well, to help answer that, I'm going to turn to this book by Dr. Sam Millam, and it's called Dirty Electricity. And in this book and in other published studies, Dr. Millam advocates that the electrification of our lives has led to an epidemic of what he refers to as the diseases of civilization. These are diseases that did not occur in populations until they were exposed to EMF from the electrical grid. These diseases of civilization include Alzheimer's, infertility, depression, heart disease, and Lou Gehrig's disease. And they also include childhood leukemia, again, which was the subject of that original report that I brought up several slides ago. Dr. Sam Millam was able to show how the incidence of these diseases and increases in the death rate correlated with the onset of electrification, independent of where it occurred in the country. So what I'm saying there, right, is when electrification rolled out, because it didn't happen when the country got electricity, got the power grid, it didn't just happen all at once. It happened in one place, then it happened in another, and then in another, and so forth, right? So when it happened in one place, these diseases started to occur there. And then when it happened in another place, these diseases started to occur there. And Dr. Millam was further able to show that these diseases did not occur in areas that never received electrification among those populations, such as the Amish. And just like with contact current, unfortunately, dirty electricity flows to our grounding products as well, like our grounding mats and our grounding sheets. Finally, we have electric fields. Electric fields are a type of EMF. It's right there in the name, right? Electromagnetic fields, it's electric fields. EMF is made up of both electrical and magnetic forces. When we talk about radiation from wireless devices like cell phones or Wi-Fi, we talk about EMF as a single force. So we measure the EMF from a cell phone, for example, and get a single number. But as we look at the lower frequency types of EMF, right, the stuff that happens down here, these types of EMF emitted by power lines and appliances, EMF is considered as two separate forces. First, electric fields, and separately, magnetic fields. So electric fields are a type of EMF, and they are a type that are emitted by power lines, wiring, and appliances. And electric fields are radiated off of anything plugged into an outlet. So once again, you are being exposed to electric fields, not only from your appliances, but also anything plugged into your power outlets, including grounding products like grounding mats. So there you have it. 3 different risks that come from grounding. These are all risks from our electrical wiring that flow into our grounding products, giving us increased exposure when we use these tools to ground our bodies. Contact current, dirty electricity, and electric fields. So what can we do? Is the situation hopeless? Do we have to give up grounding? Well, the good news is not anymore. And to explain this further, I am thrilled to welcome Andrew McAfee to the webinar. Hi, Andrew.
Thank you so very much for having me here. I really appreciate the time and the opportunity. So let me get my screen set up here.
Let me turn off my sharing and then hand it over to you.
All right, so
there you go.
Very good. All right, let's just take all this stuff off of here. Excuse me. Let me take this back. Okay. So thank you for having me, Andrew McAfee, my website, homeemftracing.com. Yes, I am electrically sensitive, and many of you probably know what that means. Basically, you become allergic to electricity. Basically, your body just starts rejecting it. It's too much, you know, hitting you over the head with a hammer saying, you got to recognize this. Your rational mind's not working here. You're exposing yourself to something. And I have done a number of small booklets to try to explain this to electricians and other building biologists of what I've found, called the Killing Current book series on my website. And I've also been a presenter with other distinguished doctors, and it's called Staying Healthy in a 5G World course on my website. I'm originally trained as a musician, bachelor's in music and a master's in conducting, not electricity. And, you know, wave your hands, things like that. You know, orchestral world, that's where I was trained, and as a performer, as a teacher. So 30 years, you know, Honolulu Symphony, New Mexico Symphony, and 15 years as the principal horn of the North Carolina Symphony, and then 10 years at UNC Chapel Hill. But it all started back when my lovely new wife and I bought a brand new house together in 2001. And within 6 months of living there, we knew something was wrong. We all of a sudden started to feel headaches and burning skin about 5 to 7 p.m. at night. We'd get this message, you know, our skin would get hot, and at nighttime our elbows would touch, and there would be a shock, and there was high. We later found out, fortunately, Charles Keene from EMF Services in Florida was coming through the area, and he fortunately was able to come by, and he found all these wiring problems. That high magnetic fields in our living room, and we had like 9 volts in our bed, and it was just a disaster. But remember, this is a brand new home. It passed all of the local codes and inspections and everything. So obviously there were things that were there that inspectors don't look for. So I have a lot to owe Charles Keene in the early days for pulling me out of that horrible situation. Long story short, fast forwarding 17 years or 16 years, I am a full-time EMF consultant, but there was a long, long road there of working with, Karl Riley. He is a terrific tracer, has set the template for me and my early techniques. And I spent about 8 years of my life working on an NC smart meter opt-out for no fee. You can get rid of the radio emitters off your house. It's still a digital meter. It's not an analog, but it's a lot better than it was. And finally, through all of my work, I was able to cut my ties with music and make a full-time living in 2017. And in 2019, I earned a career diploma from Penn Foster, an online institution that trains electricians. Now, to take an electrician's exam, you also have 4,000 hours in the field as a journeyman, and I now have achieved that. So I will be taking my electrician's license exam later this year, and I use the Mike Holt materials. Please go Mike Holt. All right, so in a couple of months, I hope to become a full-blooded licensed electrician, but right now I just have this diploma that shows I have the theory of wiring in the home. So that led to the knowledge of the wiring in the home is there were some problems I could not figure out and nobody could figure out. And actually the code prevented us from actually addressing some issues. And what are the issues? Issues is current on the grounding conductors of the home. So both in my professional work and my personal life with my own health, there was no solution for this. And clients would be showing me problems, magnetic fields and this and that. And I said, I can't cut your grounding conductor. You'd lose your breaker, your fault protection. So it really came to a head when my wife and I were both having health issues with the shielding paint in our bedroom. And every time I walk into the room, my face would burn. And long story short, we found, there were electric fields, even though we were turning the breaker off, the whole house is still on the shielding paint. And so current was getting onto that system. There's nothing I could do about it. And I had invited the best tracing people over to try to figure it out, and nothing would work. So I had to come up with a different solution. So here you see an old picture of my bench with diagnostic tools, just trying to figure out what can I do to match all the requirements, the code and blocking current, and there's dirty electricity and all these things in this. And I finally, after researching a bunch of different products that were out there, there's some that are going along the same route in industry, in big, large industrial complexes, because they got big current problems on their surfaces. So I used that as a model, and also the Dairyland people for cows. So they gave me some clues of what I could do. And after years of experimenting, I finally came up with a device, and I call it the Ncb, the Nuisance Current Blocker. So this is providing a solution to something that there is no solution for. And nobody wanted a solution for it because it would bring up a huge sort of dark horse fault of the grid itself. And we can get into talking into the multi-grounded neutral system later, and how current is being pumped into the earth and into the surfaces of our home. And so this NCB will buy us some time and protection from the electrical grid and all the wiring problems in people's homes. There are a lot of appliances, and R showed you one of where neutral current will jump directly onto the grounding conductor, and there are many, many others. So nobody wants to address this current on the grounding conductor issue. So we have to use something, and R has already said, EPRI is saying incredibly small amounts of current is dangerous to us. So we have to stop this current, and we finally have a device that can do that. Basically, it makes grounding safer. Right now, you're probably going, what? I thought grounding made you invincible and all that kind of stuff. Well, unfortunately, from my own personal experience and personal experience of my clients, it is not safe if you're grounding yourself to the home wiring. So let's address the issues. First of all, we have to get rid of the contact current. That's the most dangerous thing our body is exposed to, and it does the damage at the lowest levels. The second one is the dirty electricity. We get that. We cut the current, cut the dirty electricity. And the third one is the electric fields. And this does help lower the electric fields on grounding products. So here's a simple schematic of how it's set up. You've got a person up here that is standing on a grounding mat or bed sheet or whatever it is. And then it comes into the device. And this has a couple of different features that I won't go into today, but basically it stops the current and it plugs into just the grounding conductor. And yes, there are prongs for electricity. If you wanted to run an appliance, you could, but basically this is the blocking here and filtering on the grounding conductor. It's really easy. All you do is you just plug it in. Seriously, that's it. So if you just watch this little video here, basically you take the Ncb, you plug it in an outlet, and then you got a grounding mat. All you do is it goes right into the ground prong and you're done. So the Ncb is specifically designed for, grounding mats, bed sheets that are grounded, things that you're intentionally grounding to that will touch your body. It has many other uses we can get into later in the chat or the Q&A, but that's what I'm focusing on right now. If you're going to touch something directly, you need some protection. Now, the other part of this is it's not designed for appliances. You can, and if you're an advanced, building biologist, we can tweak it. We can make it happen if you have the right equipment to test it. But it's better not to use the Ncb on an appliance. You want your appliances solidly grounded and pulling that electric field and pulling the current away from you. And use the Ncb on devices that you will touch directly. And we can get more into that later. But basically, ground your appliances, not your body. That's the shortcut. Now, let's just look at how does this work. We want to remove contact current. So very simply, we're going to look at how you set this up. So here's your meter. Here's a Fluke 287, and you're on microamps, and the black is going to be touching the grounding mat, and you're going to literally hold on to the red lead. So basically what we have here is from the black lead into the meter, the red lead to my hand. Now, my hand is, of course, attached to my body, and my feet are touching the floor. That's the complete of the circuit. And we can talk about the circuit later. For current to flow, you have to have a circle, basically a circle. So it coming in the wall, through the meter, into my hand, down my feet, and back to its source. So I'm just holding on to the red tip here, and that's how much current literally now is completing a circuit between the black lead on this mat, which is attached to the grounding conductor, and my body. So 8 microamps is coming into my body if I hold the red lead. I lifted up the black lead, it went to 0. I put it back on the mat, it went to 8 microamps. Now let's plug in the Ncb just into the ground prong there for your grounding mats, into the wall, and now let's check it again. The black lead to the grounding mat, and I hold on to the red lead, and you'll see the current is gone. So that's a very, very simple demonstration of basically the current is being blocked from the grounding mat into the body. Now, the next one is filtering dirty electricity. And you can see here on the left side, these spikes here, this is what we call dirty electricity. So 60 hertz is, basic normal pulsation of current in North America, 60 hertz or 60 times a second. And then there's these other frequencies that ride on the 60 hertz sine wave. This is a clean sine wave over here. Riding on that, you have all of these other frequencies. And as the speed goes up, you go to the right here. This is 1,000 hertz, and this is 2,000 hertz or 1 kilohertz. You see it as the speed goes up, you have all these spikes there. And that's what it does to your sine wave. It really tears it up. Now, if you have a clean sine wave, there's none of these big spikes here, and you just have this nice clean wave here. And here's a demonstration of the Ncb actually as a filter, because if you stop the current, you stop the frequencies. Now, the first part of this is basically how you set up the equipment and engineers may be curious in that, but I'm just going to skip right ahead and I'm going to show you all these little tiny spikes on these waves are these high frequencies. And here's a blow up of it. And you can see it's, really noisy here, but after you plug in the Ncb, then it becomes clean. So that's how it removes these high frequencies. And I have other videos on ours website that show you much more in depth using the Fluke, how we can get rid of these frequencies. Now moving on to the third category, which is electric fields. And this is the setup I'm going to show you in the next slide. This is the NFA 1000, which is the best tool that I have for measuring electric fields in an area. It doesn't need a grounded reference or anything. It's just the field around it. It's going to be detecting in 3 axes, X, Y, and Z. And then there's the bed here, of course. And then there's this grounding mat that's attached to an outlet. So you'll notice the outlet is here, and that's the proximity to the head of the bed. Now, this is called a bed map. This block right here, head of the bed, middle of the bed, foot of the bed. And the power is onto the room. As you notice, I haven't plugged in the grounding mat yet, but you notice that the NFA is picking up an electric field just from that outlet. Now, if we plug the grounding mat in like the previous picture, that electric field increased to 8.9 volts per meter. So you see that there is a voltage on the grounding system. That energy was brought in by the grounding mat into that area. And installing Ncb, this here now reduced it from 8.9 to 7.8 coming in on the grounding conductor. So that reduces the electric field that you would be exposed to otherwise from a bare grounding mat. 3 things eliminated, 3 things addressed: contact current, dirty electricity, and the electric fields are reduced. It does not remove all of your electric field because that's a larger issue to get to, but at least it reduces it when you use your mats. Grounding is important to our lives, to our relationship with the planet. Unfortunately, our homes are so dirty with their energy. It's just not the best way. But if you're going to be using grounding mats, if you have to in your high-rise building or apartment or something, the Ncb is your answer to clean up and stop the contact current. Thank you, R, for recognizing this critically important information and bringing it to your audience.
Thank you very much, Andrew. And I will reclaim power from you and share my screen again. Okay. So again, thank you so much, Andrew, for explaining. Oh, is my camera? I forgot to turn on camera. For explaining your brilliant invention to us. Now, before we get to Q&A and the special offer I have for all of you here tonight, I want to underscore a couple of points. One of which Andrew already said, which is the Ncb is the first and only product in the world that does what Andrew just explained. That's why he's filed a patent on it. You cannot find this functionality in another product anywhere. And I also want to underscore, Andrew invented the Ncb not to get rich and not just to solve a theoretical problem, but to solve his problem and his clients' problems. This stroke of genius was born out of necessity and real world needs. And that's why I'm excited to share a special offer with all of you here in attendance tonight. So for all of you here in attendance tonight, you can save 33% as the launch. This is the first time this product is available for purchase. And for tonight only, that's through midnight tonight, which I haven't checked, but that's about 8 hours from now. You can save 33% with free shipping at shieldyourbody.com/ground and enter the discount code GROUND33 at checkout. It may be obvious, but I want to underscore this product is only available for North America at this point in time. As you know, outlets are different, and not only outlets, but the grid is different. But right now, this model will work in North America. So that means this is available for customers right now in the United States and Canada. So again, this is through midnight tonight Pacific time. You can save 33% with free shipping. I'm going to be announcing this to the list tomorrow, but the discount they're going to get is a lot less than those of you who took time to show up tonight for Andrew's presentation. So with that, I think we can open it up to some Q&A. Andrew, are you ready?
Yes, sir.
Okay. So let's see. This first question is long, so brace yourself. Rob asks, I have a clamp meter and tested my incoming copper water supply, and it showed 19 milliamps. I have a thick ground copper wire hooked up to the water heater incoming line that looks like it goes to the outside of our house and into a ground stake. I'm not sure exactly. When I use my clamp meter on other pipes in my house, I get a 0 reading. Do you think that the water heater ground line is taking care of all of the ground voltage?
It's a really good question. And, without seeing it first off, that's too much to assume right off the bat. So ground voltage, that's an interesting term. We probably need to go into that a little bit, but you'd have to show me all the amp clamps on each of the grounding systems. But basically what you need to know, if there's any current on grounding systems, either a ground rod or water bond or anything, that's vicariously going to swim around all of your grounding system of your entire house.
Okay, thank you. Okay, here's a good one. It's from Anonymous. What is the difference between what you are talking about today compared to dirty electricity filters?
Dirty electricity filters are only primarily dealing with the hot and the neutral. So what the hot and the neutral is, if you're looking here at the top prong, it's the two eyes on the face, and then the ground prong is the tongue sticking out. So the hot and the neutral.
Right. So I have my camera. I have the NCB up here, and it's the two flat prongs are the hot and the neutral, as opposed to the
right. So the current comes out on the hot, goes through the light or whatever it is, and comes back on the neutral or the return wire. So basically what a lot of filters do is they jump the high frequencies to your neutral. So any of the high frequencies that are produced is just basically, they just, as your garbage can, just dump it onto the neutral and goes back. Now, there are some filters that are 3-prong, and some of that gets dumped to the grounding, but I'm not going to say which brand and how much and all that. But basically all you need to know is, as far as I know, there are no other products that intentionally filter the grounding conductor. Most of them are 2-prong and only filter the top blades.
Thank you, Andrew. Okay, next up we have Rob again. Also, can I confirm ground current with my clamp meter by using a ground stake somewhere in my lawn?
All right, so that's two different things. Ground current. Well, you'll have to add here. I mean, do you want to know how much is coming in to and from the grid?
I don't know how easy it's going to be for him to answer that.
So let me just kind of jump this.
Just to make assumption.
If you're going to clamp over what's called your grounding electrode conductor, and that's the wire that's basically a big rod in the ground that's required by the code. Your neutral comes into the house and then it gets stuck into the ground. That ground rod right there is called the grounding electrode conductor. Excuse me, the wire going down to it is the grounding electrode conductor. Conductor is a wire. The grounding electrode is the stake. So if you clamped over that, that's basically showing you how much current is communicating from the primary side of the transformer into the earth. And that's how much circulating at that point. We don't know how much is coming into your actual house yet. If there's another point that goes to earth over here, there's definitely going to be current circulating into your home. So if you're just going to put another ground rod in the earth out there and try to see how much is coming to and from two places that far apart, sure, you're going to get probably 100, 150 milliamps of current, maybe only 4 milliamps, who knows? Sure, there's a certain amount, and you can also move that stake in your yard and it'll go up or down because there's like little rivers of current swimming in your yard that are coming straight into the to and from certain directions. So we could go a lot of different directions with that.
Thank you. Jumping ahead here a little, Diana asks a very good question. Can you plug a grounded circuit extension into the NCB to plug in and protect several items?
You could. It depends what they are. I've explored this where if you have one NCB and you have two different grounding mats come into it, that's not ideal, because if you imagine one person is on grounding mat A and one person's on grounding mat B. If person A and B touch each other, they are actually creating a circuit between the NCB to the mat, between the people. So that allows current to flow right there. So if one of them got energized, that would circulate amongst them right there. So the key is you probably want home runs, one mat, one NCB straight in. So if any current got onto you, it would go straight to the NCB and activate the ground fault protection.
Thank you, Andrew. And so David, I believe that answered your question as well. So Greg asks, is the NCB the same as a Graham-Stetzer Stetzerizer filter? And I think you answered that just a little bit earlier, right? With when your comparison.
Correct. It is not.
To dirty electricity. Okay. Thank you. Let's see. Okay. This is a good question. My grounding mat only has the one prong that goes only into the grounding hole of the electrical outlet, not into all three holes. Would you still need the NCB? Oh, she signed it, Gwen. So yes, Gwen, the answer is it will work. In fact, it's designed really to work with that one prong, just the grounding prong, right? Right, Andrew?
Yes, the grounding prong is what's addressed. The NCB is allowed. You can actually run an appliance stuck into the NCB, but basically what's filtered is the grounding prong. The grounding prong is what you want to utilize if you want to protect your ground mat.
Yeah, I'm just bringing up a photo here to show Gwen what we're talking about, right? So this is, in a lot of use cases, this is how you would use it, right? You'd have your grounding cord, and you would just go into the ground, the ground of the outlet, not all three.
Correct.
Slots. Okay.
Correct.
Thank you, Gwen. That was a very good question. Okay. Mary asks if there's a way to check the electricity in the ground by your house.
Absolutely. Yes, that's a terrific question. I do it all the time. So one of my videos, I have actually dowsing rods, and I'm actually tracing these little rivers of current because my client wanted to know where's a clean grounding spot out in my yard. So I go, okay, I'll go find it. So we found that some of the current would cross, and that place where it crossed all of a sudden would have this, even more current. So we definitely don't want to stand where the current is crossed. In fact, let me share my screen to tell you.
Sure. Give me 1 second. I'll stop sharing.
Let me show you on
power. There you go. Oh, there you go.
So on my NCB website, on my website under NCB, you scroll down and see this current flows in the yard. There's actually a video on there that shows me doing this. And here are some of the paths that will, come to this transformer, to come to the ground rod. And definitely you don't want to be standing here at 530, but you can stand in between. So that's one way to do it is, by dowsing. The other one is you literally put a ground stake in the earth, like the gentleman was saying before. You put the black lead at your grounding electrode conductor, that wire that gets grounded at your service, and your red lead out in the yard. And you can tell where these rivers are current are flowing to and from that place. And you can see the low spots or the high spots. I hope that answers the question.
Thank you. Yeah. Let me just resume the screen sharing so everyone has Great. Thank you, Mary. And Mary, I pasted the link that Andrew was talking about into the chat. Okay. Stuart asks, in the past, and by the way, Andrew, we are getting quite a few questions here. So I hope you're comfortable in your chair there. Stuart
Yes.
asks, in the past, I understood that the grounding needed also to be grounded outside. And that's the question. So do you need to ground to the outside?
There are some strategies where if you have a bed map or a grounding mat or bedding or something, instead of grounding to your home electrical in a plug, if you do a solitary line out to a yard stake in the yard. And sometimes that's much better because, obviously you're in the soil and it's not directly related to your home electrical system and all the appliances that are pushing current in there. So there are sometimes that is a better solution than grounding into your home. I found actually that if you have a secondary, what's called an auxiliary ground rod in the code, if you have another ground rod outside, that is a secondary place for current to flow in and out of the house. So if you follow that line to your bed, so that bed map now is the bed sheet is now attached outside, but the inside wiring is going to be pushing and pulling. Can I go outside? And the outside grid current is going to go, can I run to the inside of the house? So there's going to be what's called capacitance. There's these two plates and the energy is going to try to jump across it. So you got to be really smart about how you set something up like that and use a building biologist. Of course, always turn the power off to the bedroom. Just try to lower the interaction between these two fields and just pray that if ever lightning comes and there's the energy that surges in the earth, that you're not on your bed unless you have the Ncb.
Thank you. Okay, so Lori asks, I am planning to use EMF paint in my house. How should I ground it safely in view of this new information?
That was my presentation, Staying Healthy in a 5G World. I don't believe that there's a blanket statement to say that there is a safe way to do it. I don't believe there is. The best thing is to use fabrics and other types of non-grounded shielding material. If you have to, for whatever reason, then we're getting into, okay, you're gonna shield it with paint, and now you're gonna ground it to what? You're gonna ground it to the inside? Code says you should, because if it's likely to be energized, you need to be associated with a breaker to turn it off. So these walls are likely to be energized by something in that room. So you have to have a breaker that turns that room off. So that means that is grounded inside. Now, if you grounded it outside, we have the same issue as what I brought up before, is we have this. Actually, let me just share the screen real quick, if you don't mind. We keep coming back to this.
Yeah. Good.
And I want to.
Yeah, I need to. Oh, right. I need to stop sharing and then give you the power.
Since this still keeps up over and over again, let me. So we're talking about. I'm going to jump ahead here. Electric fields interchanging with, kind of going back and forth between each other. So if you have an outside ground rod and it comes up to your shielding wall here, that energy is going to be pulsing back and forth 120 times a second, 60 forward, and twice per cycle, forward and back here. That's AC, because everything in the earth is basically getting pumped on by the electrical grid. So there's current everywhere. So it pumps in the grid current into this wall. So this is turning plus and minus twice a cycle, plus and then minus. That's one cycle. Plus, minus, that's one cycle. These electrons, the plus are going to pull on the minus, but the plus are going to push on the plus. So all of a sudden, the pluses push across this wall. And what happens is you're energizing this surface, but it's pushing and pulling on other things in the surface of that room. It could be you. We don't know. So the whole problem is we have this interaction of naturally occurring molecules and electrons, but then we have this push-pull dynamic inside of the room, and you stick your body in there, it's going to start pushing and pulling on the electrons in your body. And then we start to see what this happens is these electrons start to align. The negatives get pulled to the positive, and et cetera. And you've got a bunch of issues. And then we get into this issue, and that's actually your cells and getting into the voltage gate calcium channels and that interaction, which, you know, the electric field out here pushes on this, forces these gates on, you know, and we're talking here about the grid, which is pulsing forward and backwards 60 times a second, and you're pushing your body on this, and you're standing right in the middle of it. It becomes a very, very complex issue. And I have lots of things that show the voltages rising and falling around here. And we can get into this more, but that's just a snapshot of what we're talking about.
Thank you, Andrew. Now, Genevieve posted a question. I just happened to see it in the chat. Everyone, just FYI, I just happened to see this question, but if you have a question, please post it into the Q&A pod. That's a separate button on the bottom of your screen. That way we'll definitely see it. But I wanted to pull this one out because I suspect many people will have a variation of this question. And I know it's probably something you want to address as well, Andrew. Isn't the point of grounding to discharge the body voltage? But the NCB showed no current flow in the demonstration video. How do we measure the body voltage discharge?
That's a really good question. How do you measure the actual discharge? So I could think of a couple scenarios. If you rub your feet on a carpet and you build up a whole bunch of static electricity, you know how you play with a balloon and it kind of like, you know, sticks on your hair and all that kind of stuff? That's static charge built up on your body. And then of course you shock yourself and you discharge it, right? So there is a DC direct current game you can play with, like things, if they're going to glob onto you, that's static electricity. So AC, how are you going to tell if your body is discharged of AC? I don't know. And actually, I don't think you want to know, because I don't think you want to actually have current moving through you ever. And that's the whole purpose of this presentation, is you don't want current flowing through you. So the way the skin holds its energy in capacitance is literally, the skin is a capacitor. And I just showed you the two plates on that screen. So the skin has impedance. It's a blocking source. It blocks current to a certain extent because it has these two barriers in the corneum or whatever, the skin layers. And it blocks DC more than AC. AC is allowed through because AC will jump from plate to plate, just like a Graham-Setzer filter. That's a capacitor, and then high frequencies jump from plate to plate. So you literally don't want current going through your body, especially if your hands get wet, this blocking ability goes to zero. And if you have high frequencies, this blocking ability goes to zero. So the worst thing that could happen to you is if you are so-called discharging and actually current is moving through you. What I'd like to think is that this energy inside of the skin that's holding this charge can slowly dissipate. And I believe the resistor in the NCB can allow things just to trickle out very slowly. Because one is current and the other one is actually electric field. Presence of electric fields. You want to get rid of your electric fields and your body's going to start processing out that stuff anyway. But if you go out and you stick your hands on the earth, I believe that this excessive charge will basically just kind of migrate. It's not going to be like a sudden jolt or harmful circuit of current through you, but you want a slow dissipation over time, which I believe the resistor can do, or just going out and being on earth. It's a complex question. I've never thought of it as, how do you measure the dissipation? I don't know the answer specifically to that.
So then a related question also just popped up in chat. And after this, I'm going to stop taking them out of chat because we do have a lot in the Q&A pod. But Sanaz, I apologize if I'm pronouncing that wrong, or I most certainly am pronouncing that wrong. Isn't the best tool to use body voltage meter to met? Oh, it just jumped. Isn't the best tool to use a body voltage meter to measure how it reduces your electromagnetic sources?
I would love to share a screen again if you don't mind.
Yeah, I did not pull authority.
Great, very good. All right, so body voltage meter. So let's just get some definitions quickly. A body voltage meter is some sort of multimeter, and a multimeter is basically, if we agree that the multimeter has basically got a little digital readout in the bottom, at the top, and has a black and a red lead, and you're going to test something. So let's just call that a body voltage meter or a multimeter. I'm going to call them the same thing. So is it the best way to measure, what is the specific thing are measuring what?
The reduction in electromagnetic sources. So a reduction in EMF exposure.
The reduction. Okay. Is it the best way to measure? And the answer is no. And here's why. Most people set it up wrong. So I'm going to show you the fault with using a body voltage meter or a multimeter to test anything associated with the body. So as you can tell in this picture right here, the multimeter, all it does is the black lead is always 0. So what do I mean by this? What I mean is sea level is 0, right? How do you know what altitude you're going to go camping at? Well, compare it to sea level. Well, what happens if you change the sea level? You drop the sea 1,000 feet. What's your campsite now? It's 6,000 feet because there's a greater difference. So that's basically what a body voltage meter is doing. It's basically, this is sea level. The black is sea level. So the red lead now is compared to sea level. So what altitude are you at? So if you have your black lead, and you notice on the right side here, I use a hot leg of an outlet. The right side blade is the hot lead. That's where your voltage is, and it's very dangerous. Let's call it 120 volts if you compare it to ground. If you put both your leads at that same point, guess what the voltage is? 0. Because you're measuring sea level to sea level. You're measuring the same exact point. There's no difference. So if you move your black lead over to the neutral, which is grounded, so that would be very, very different from the 120 leg, then you will actually see the multimeter say, oh, that's a difference of 120 volts to wherever the black is. So the way people set up the meter is the problem. I would rather you set up the black literally on your hand. You are the 0. And then use the red lead to touch things around you to see how much of a difference from your body. Now we can go the opposite too. If you want to try to test your body, what is your 0 going to be? What's the black lead going to be attached to? You got the grounding conductor in the wall, which is contaminated and basically the same voltage as the grid, as the primary side of the grid. Or you go out in the yard, which is being energized by the grid. It's probably better in the yard. It's your best 0, whatever it is. So what are you comparing? This is a great topic, and I want to get into it eventually with the multi-grounded neutral and what is 0? What is our ground? So the answer is you need to use the NFA 1000. That's the best meter for determining actually what the presence is and the reduction. Power on, power off. What's the field in the room? And the NFA does it without a grounded reference. Hope that answers the question.
Thank you, Andrew. Next up, we have Barb Payne. Hi, Barb. Do you leave the NCB plugged in 24/7, or do you merely plug it in when you want to directly use something that you'd plug it into it?
You're welcome to leave it in all the time. It doesn't do any filtering of the home or of the circuit. Only what you plug directly into the NCB will it filter.
Yeah. Okay. So you can leave it plugged in 24/7, but it doesn't bring you any benefit unless you're actively using the product plugged into the NCB.
Yep.
Thank you, Andrew. Rob again asks, how does the NCB work if my home ground wires go to the earth outside my home? The earth has a lot of stray voltage.
Okay. So let's say you're grounding your bed sheets to the outside. I do have a device for that. And it's not the NCB. It's the it's the Pro, and we can talk about that later and offline. So I have other devices for using a ground rod in the earth, bringing a grounding conductor into the home to give you, that initial protection from shocks, from, lightning pulsing in, all this other kind of stuff. And we can get into that later.
Yeah. So, and everyone, so the NCB is the product we're launching tonight. There is also a professional version that we will be launching in the near future, and that requires professional installation. It has a different feature set. So that was what Andrew was just referring to. And if you're interested in that, just stay tuned for further updates. Okay, thank you, Rob. C. Voitas, I apologize for the mangling. Do you need just one? And I think right there, the answer, Andrew, is you need one per grounding or earthing product that you are using at a time.
That's the safest way to use it. You could put multiple things on there, but I can imagine scenarios where you would not get all the protection you wanted.
Thank you. Okay. Spark asks, if you are disconnecting the grounding conductor with the NCB, how, I guess you know Spark.
Hi, Spark.
I just got to ask, is Spark his real name?
It's his nickname. He has another name, but we don't.
No, that's fine. No, that's fine. I was just wondering if his parents predicted his career.
Yeah, ask him.
If you are disconnecting the grounding conductor with the NCB, how is the grounding mat any more for a grounding mat? Why not just don't use the grounding mat?
Yeah, these were all choices that we're all free to make. But if a person is bent and I'm going to use my grounding mat, or they really have some sort of a use, we can get into later the professional uses for the NCB. There are a number of other ones, but just sticking to the grounding mat thing, I can foresee some situations like you're in a hotel room or something, you have no control over the environment and you want to use your NCB to, pull some energy out of an area or ground something or something. You want to have the variability that comes with the NCB, and it does have some things you can adjust.
Thank you. And also, I'll throw in here, and Andrew, you can modify, amend, or correct, but the NCB isn't just for grounding and earthing products, it's also for EMF protection products. So if you have a EMF bed canopy in an area with high electric fields, right, that would be another instance where you would want to use the NCB. Is that correct?
That's right. And I don't know how much you want to get into the dial and adjusting that, but if you have the right equipment, you can actually tweak it to a specific application.
Thank you. Okay, Terry Hassler asks, great job, Andrew. Trying to understand, if the purpose of grounding is to dump our excess electrons to ground, shouldn't there be some kind of current on the mat grounding wire?
The message here from EPRI is literally any measurable current is very damaging. The principle of current flow, especially AC current flow, is what we're talking about. Grid current flow, not the natural DC from the earth or whatever exchange that is. Let's just leave that aside for a second. Any AC current is damaging to the body in all the ways that you can imagine. Free radical damage, ionization, all these other things. So any current moving through you is bad. That has to be stopped. Now, it forces the issue now. When you start learning about why am I using the NCB when I could just turn the power off? Hey, that's great. Turn the power off. I totally encourage you to turn the power off. That will get rid of your electric fields more than anything else, is de-energize the circuit. But if you have to use a grounding mat or a bed sheet or a shielding canopy, and you cannot control all of your environments, you can't clean up the wiring of your house, you're staying at a guest house or something like that, and you need to make sure that you're not going to get fried by their current on their grounding conductors, you better have that NCB.
Thank you. Barb asks, is it okay to touch the NCB after it has been plugged in for a long time, such as when you want to move it to a different outlet? And again, Andrew, jump in and correct me if I'm wrong, but yes, it is perfectly safe to touch. It is a hard plastic case, so non-conductive casing. Touching it, even when things are running through it, is totally fine, correct?
That's it. And even after I was testing it, tripping breakers and everything like that, It has no ability to maintain a capacitance or hold any energy in itself. So it's not going to electrocute you at all. It's not possible for it to discharge onto you if it's free floating after you pull it out of the wall.
Thank you. Greg asks, is that $199 per unit, and how many do you need? The answer is it is $199 per unit tonight. Normally 300 per unit. How many do you need? You need one per product that you want to plug into it simultaneously, right? So if you have, 3 different grounding mats, but you only use one at a time, you'll only need one NCB. But if you need to use all 3 at once, you will want 3 NCBs. Thank you, Greg. Okay, this is kind of an open-ended question. Andrew, take it as far as you would like to. Is the NCB only useful for grounding equipment? And that's Amy asking the question.
Only useful for grounding equipment. That is its primary function and goal. So only useful.
Well, another use would be for grounded EMF protection, right?
So I'm trying to think of other than the ground prong, other than filtering the grounding conductor. Maybe I'm missing the question.
Oh, no, that's okay. I'm going to move on then to the next question. Okay, this is a good one, I think, to help clear some things up. Raymond asks, do you have to plug in the NCB into every electrical outlet to stop the dirty electricity? And yeah, no, why don't you go for it, Andrew?
Yep, it's only to block one grounding mat attached to it. It'll block the circuit and what would flow to and from that one grounding mat. It will not affect the rest of the circuits of the house.
Yeah, so this is not a dirty electricity filter in the sense that it removes dirty electricity from the home. It's a dirty electricity filter in the sense that it removes dirty electricity from the grounding product plugged into it, right? Is that
correct? It protects you, protects your grounding mat.
Thank you. And thank you, Raymond. I am about to post a link in the chat for those who might be interested. Andrew has referenced this, and I'm just going to post it if people want to see. There are other uses for the NCB. These are more really aimed at professionals, such as building biologists. But we have instructions on this page that I just pasted into chat that explains what those functions are and how you can make use of them. Barb asks, and thank you for all the questions, Barb. Do you have to turn off the circuit breaker for the electrical outlet you're going to use? What about other circuit breakers? That one let's start with the first question. Do you have to turn off the circuit breaker for the outlet you're going to use?
No. The circuit can be on, it's live, it's hot, and the NCB is plugged into a live outlet, and then you have your grounding mat or bed sheet or whatever it is plugged into the NCB, and it protects you from the effects. Now, you will get much, much better results if the actual circuit is off to that bedroom, because the overall electric fields in that room will be lower and you don't have to manage as much.
Okay, thank you, Andrew and Barb. Okay, Anonymous asks, is the NCB suitable for use in the UK? I heard you mention USA and Canada. Right now, and Andrew, I'll ask you to jump in, but right now, the version of the NCB that we have is only for use in North America, and it's only available for purchase in the United States and Canada. But Andrew, do you have something else you'd like to add on that?
The Pro version, you could adopt that very, very quickly to just any grounding conductor anywhere in the world. As far as the plug, yeah, I cannot say that it's for anywhere else other than North America. There are too many other little tiny details for me to say that it's, yeah, you can use it anywhere else. There's these little tiny tweaks that have to be taken care of first. We can make it available, but let's first things first.
Yeah, let's, this is a big step for us, Andrew. Let's, yeah, we'll wait. But thank you, anonymous attendee. Okay. This is sort of an open-ended question, Andrew. Not sure if you're going to have an answer for it or not. But Michael Shepley lives in an apartment building built in the 1920s on the 3rd floor. Does he need grounding, and is the best way to have grounding to buy a mat of some kind?
So the whole argument that we're pitching here is we've discovered some horrible information, just some devastating news that has to reset the entire medical standard. And that is there's current swimming all over grounding things. And we have to make sure that we're not getting current swim into us. Now with old buildings, old homes, I can say 100%, they're not grounded. There's no grounding conductor, but there are electric fields everywhere that are massive, and maybe in the old building too. But the buildings are different than residential. Buildings have metal clad, or BX is this metal tubing around the wires, and that will absorb the electric fields if it's appropriately grounded out to the earth, back to its source. But you'll only get 2 prongs, but the actual metal box is actually grounded. So it actually is technically grounded. It just, you don't have 3 prongs. So I don't want to get too complex on this, but actually in buildings, your actually electric fields actually be a lot lower because they have this BX or MC cable. Than in residential applications, that we don't have this MC or BX that contains the electric field. So do you need grounding? The whole thing is you're going to have massive electric fields. What are you going to do? If you can't turn the power off to reduce the electric fields, a lot of people use grounding to pull the electric field out of environment. Now, this gets back into this play of push-pull. It's a very dangerous business unless you have something like the NFA 1000 and really know what the actual effect is when you start grounding things. So in general, turn the power off, get rid of the electric field. That's the first goal. Beyond that, if you start having to do grounding in order to remove electric fields, ground appliances, ground metal objects. Don't ground your body directly. That's the best advice I can give you.
Thank you. And thank you, Michael. Okay. The number of questions in the question pod keeps actually growing, no matter how many we answer. So I'm going to start skipping around a little bit. We'll try to answer as many of them as possible. Okay, so Gabriel asks, when will these be available for Europe? And will you do wholesale for grounding product vendors? 2 separate questions, and I'll just jump on those. The Pro version will be available for Europe, and that is soon. We don't have a firm date yet, but that is soon. And yes, we offer wholesale for grounding product vendors. The Ncb, the one you're seeing tonight, will be in our distributor catalog tomorrow morning. And then the Pro version will also be available for distributors when that is released. So thank you, Gabriel. Okay. Okay, so Florence asks, could you touch on other uses for the Ncb? And so that I'll paste that link again in case you missed it into the chat pod, Florence, and that is the link to the page that explains other uses for the Ncb. By the way, if you have questions and we don't get to them tonight, and it's increasingly looking like they're, I mean, we're still going here, but just based on the number of questions that keep coming in, it looks like there'll be some we don't get to. So feel free to email hello@shieldyourbody.com and we will get to them as quickly as possible. But thank you, Florence. Okay, Mana asks, I have a dirty electricity filter near the circuit breaker. Can the Ncb be used in place of the dirty electricity filter?
Nope.
No. Nice, simple answer. Thank you, both of you, Andrew and Mana. Okay, that we answered. Okay. Well, and I think I know your answer to this, Andrew. But do you think that in some instances, if someone used a grounding product with the Ncb, that they might still be causing more harm than good by using the grounding product because of the electric fields not being completely eliminated or for any other reason?
As I've shown, the situation.
Speak your mind.
As I've shown, the situation is better with the Ncb. It is better
Excellent.
with the NCB.
Thank you. Very good. Okay, Janice asks, will this device help people who are not using grounding devices like grounding mats?
Yeah, there are some other applications for it, and I have a video on it. A spectrum analyzer cleans up your ground so you can see the frequencies. If you're working at a station and you have static protection, you don't want to be, of course, electrocuted and all that kind of stuff. You use it for that. It just goes on. And I haven't even got into the talking about the dial and adjusting and actually checking your GFCI breakers in your home. I mean, there's so many other things that we can do, but these are more advanced things. But basically, to keep it simple, today is about grounding mats and bed sheets and anything you have to ground and that possibly would make contact with your body.
Thank you. Okay. I'm just scrolling through questions here. A lot of the ones here we've already answered.
You mind if I
Daniel asks, oh, yes?
Oh, if you got a question, go ahead.
Yeah, Daniel asks, in other words, if there are high electric fields, is this advised to be used for grounding sheets?
Well, I turned that question around. If you are using grounding sheets because you have high electric fields that you can't control, like you're in an apartment or you're staying at a friend's house and then you're forbidden to go to the basement to turn off the breakers, and you have high electric fields and using bed sheets and you're using them the correct way, the highest electric fields on your floor from people below you, and then you use your bed sheet under you and it sucks the electric field away from your body. You're on top of your bed so you can pull these electric fields down. Absolutely. You want to make sure that there is no current swinging around. You can actually adjust the dial inside the NCB to allow a certain amount of current to flow and to reduce the electric fields in a certain amount to balance out the safety. I mean, it gets a little complex, but the answer is yes.
Thank you. This is a good one. And Andrew, if you want to share a screen, just let me know. Linda asks, what is the mechanism inside the NCB?
Happy to show you that. So I'm going to share a screen.
Give me 1 second. I need to, these windows keep changing.
Hey, Ard, you had that complex schematic somewhere early in the, where was that?
Oh, that
I can
was
just
in
show them the
video,
simple
I think, the one
schematic
you're
on how to set up the bed map. That's probably the easiest thing to do. Let's do that. Let's go back to our presentation.
Go for it.
All right, we're going back to our presentation and I'm going to pull up slide number. Almost there. There it is. So taking a look at this.
You need to share your screen.
Thank you. I should have done that first before I got into this. All right, share screen, bang, share. Now I can play this current slide. Okay, now you see a little person over here on the right, and then here's the schematic, and then there's the outlet. So let's look at our schematic here. Coming in, this little jagged line is the universal term for a resistor. It basically linear performance, very stable, no problem. It's just going to slow down current or stop it. And it's depending on how much it is. That's a 1 mega ohm resistor right there. And then after that, there's actually an inductor. It's a coil designed to stop frequencies, low frequencies and higher frequencies. Basically, it's, you got noise coming through here in any way, it's going to, choke it. The opposite path is what's called a gas discharge tube. It's basically a neon light. And this activates at a certain voltage. And if there's a voltage that rises on here, this thing lights up and the current will rush through immediately in nanoseconds. I mean, just really super milliseconds, super fast. So it bypasses all the resistors, takes another ones. So if you get this energized, it goes bang and sends it back onto trip to breaker.
Thank you. Let me mark that as done. Someone else asked, and I answered it in text, but Andrew, someone asked if you are available for consulting. And I pointed out your website, homeemftracing.com, is how people can reach out to you.
Right. You go to my appointments page, read the details there, and it's pretty much self-explanatory. I'd be happy to help.
Okay. Let's see. If using the NCB, do you think it is unnecessary to turn off the power to a room where you are using a grounded product?
In my personal opinion, it's always better to turn the power off unless you have MC cable. If the room has been rewired into MC cable and it contains all the electric fields, then you don't have to turn off the power.
Okay, thank you. Just a moment here, Stephanie is asking me to ask the room. I guess there's a Lori in the room, and to please type into the chat pod where it is you are trying to order from. That is, I guess, your shipping address. If you could please type that into the chat, Stephanie would be happy to help you further. Anonymous asks, is grounding at the beach safe?
As far as I know, unless you got some weird problem going on, the beach is like one of the greatest places to go. And, parks, woods, whatever it is, get out in nature. Don't be afraid of nature. Of course, you want to be walking underneath a power line or something like that. Just don't stick a ground rod in the earth and then hold on to it, and try to actually bring current out of the earth through your body. Just go out with your feet, your hands, enjoy the weather, enjoy the earth. And it gets into a larger problem talking about the multi-grounded neutral system of the, that's the basic where we're going to end up this conversation. Everybody's going to get, kind of like, well, and it's always going to go up, and boom, we're going to have to talk about the multi-grounded grid eventually. But in the meantime, let's just talk about how to stay safe in your own home.
Thank you. Jane asks, and I should have this information, but I just don't have it handy. How much does the device weigh? And Andrew, I don't know if you happen to remember offhand how much it weighs, but it's very light.
I did weigh it for shipping.
Yeah.
I don't remember.
It's Jane, it's very light. I mean, we're talking a matter of ounces. And she's asking because she wants to see if it's possible, how convenient it is to travel with. And I would say it's quite convenient. But thank you, Jane. That's a very good question. And I apologize for not having the exact answer on hand for you. Okay, so here's Daniel asks, and this is actually sort of what Lori was asking too. Do you use your NCB in motels or other places when you are traveling for grounding purposes, or just to find a spot to ground when you can?
When you travel in buildings, residential areas, that's where it's needed, not outside.
Thank you. Someone is asking, Raymond is asking if the NCB does the same thing as a sign tamer.
No.
Do you want to elaborate?
The sign tamer is they have a couple of different products. One's a whole house filter. Basically, it gets stuck into your main panel, hot, neutral, two hots, neutral on the ground. And it's hooked up in parallel. And what parallel is, if you have a wire and then you plug in something attached to it, it doesn't disrupt the wire, but you can go through my right hand. It can go with this finger and this way. So it has two pathways, one in here and one here. So that's basically how the sign tamer is plugged in, is it kind of tries to bleed off some of the frequencies that come into your house. And for the most part, is effective in some areas. But mine is what's called in series. It's basically all the current goes through my grounding conductor. Theirs is in parallel, mine's in series. I don't filter the hot or the neutral too. I'm not concerned about the hot and the neutrals at all. I am focusing only on the grounding conductor.
Thank you. Okay, Gabriel asks, when you say the neutral is grounded, what do you mean? I live in Europe and the neutral is not connected to the grounding cables in the panel. It is separate.
May I share my screen?
Yeah, are you not?
Yeah. You're good. No, all right.
Yep.
Thank you for that question. So can you see the NCB page. You good, R? Okay.
Yes.
So on the NCB page, you're going to go down on my website, NCB, go down and you're going to find current flow whack-a-mole. Here's some of the EPR research. 60% goes through the earth in North America. I'm not sure what it is in other countries, but we have a multi-grounded neutral system. And what does the multi-grounded neutral system mean? It means multi, a lot, grounded into the ground, neutral. The neutral is the center tap, the neutral point between two extremes on the transformer. Here's one extreme, here's the other extreme. Right in the center, it's called the neutral point. So they call that neutral current. It's not neutral because there is current flowing. So neutral is a really bad word. So unfortunately, it's the neutral point of the transformer. It's a center tap. That brings back 120 volt current to the system. Here's the kicker. This ground rod from the here's the current that comes in what's called the primary side from the substation. This is the primary side of our transformer. The return current pathway is grounded. It gets stuck into the earth. So it has a choice. It can go on the wire. It can go into the earth. Now, on the other side is the secondary side. This is the house side of the transformer. And we have 120 volts positive, 120 volts negative. So right in the middle is our neutral. It gets stuck into the earth, boom, right there at our panel. But look at this. There is a wire that connects the primary side of the grid to the secondary side right there. This wire right here is the problem. That bond right there is one of the big stinks about all the neutral current and the noise. And this is a lightning arrestor right here from the phase conductor coming in. This is also grounded to our neutral. So we're getting hit with a bunch of noise, bunch of electricity, bunch of surges right into our neutral. And the neutral comes in and right here, it becomes a part of our grounding system. So here's another picture. The neutral comes in, boom, hits the ground right there, but then it splits into the fourth wire. This fourth wire is the equipment grounding conductor. This is the thing that you plug in all your outlets. This green wire right here goes to the frame of all your loads. So you see it's required by code to be bonded right here. It's called the main bonding jumper. This grounding conductor is attached to this neutral, which is grounded, the grounded conductor, right here at the main disconnect. So all of the grid crap that comes in on the neutral also goes right into our grounding mats and outlets and surfaces that we touch.
Thank you. And thank you, Gabriel, for the question. Mary asks, we live in high desert, dry climate and use a clothes dryer, makes a lot of static electricity. Could improper grounding increase that?
It's hard to know. There are different properties with really dry desert air and static electricity and all that kind of stuff. I am not a specialist in that, but I do know about if you're applying, let's say your dryer is a 3-prong. That means it's too hot and the third wire is a neutral. Just like that picture that R showed earlier, that thing is grounded to the frame. There's going to be a much more current and electric field around the frame of that. That will be interpreted as, more static discharge or whatever you want to call it. It should be a 4-wire system, 2 hots, a neutral that's carrying current, and then a grounding conductor that's attached to the frame. So I would check that to make sure that that's not the problem.
Thank you. And thank you for the question, Mary. C. Voitas asks, he understands that we're saying that this product is really designed for use with grounding products as opposed to appliances, but he asks, or she, apart from grounding products, what about, say, a sewing machine that you touch constantly?
Yeah, sewing machines are a real big problem. I've actually worked with a lady that she really got me into it, and they're a disaster. And what we ended up doing, we actually put an alligator clip onto the frame of the sewing machine and then grounded it. So we were pulling away current, pulling away electric fields from the frame of the sewing machine. So we provided a better pathway than her body. Like I said before, your skin has some impedance on it. It blocks to a certain extent. So it's taking all paths, but if you get a better path, you can suck it away from you. So you would not use it on your sewing machine because that would rob it of a better path. We actually want that sewing machine grounded better. Now, if the person were required to wear some sort of strap on themselves, I would put the Ncb on that. So the basic premise is don't use the Ncb on Ncb on appliances. Add more grounding to appliances to pull that stuff away. And we can get into computers and laptops and all kinds of stuff. Whenever your body touches something constantly, you want to make sure that path isn't bringing current to you. I hope that explains it.
Yeah, that was a great illustration. Thank you, Andrew. And thank you, C. Voitas, for the question. David Freund asks, and hi, David, is grounding using the Ncb with shielding paint the same as to a canopy? Are those kind of similar use? Okay, you'd use it the same way, same benefits. Is that right, Andrew?
Yes. And in all cases,
Oh.
it's better to turn the power off, especially if you have shielding paint. Remember the walls, unless you have MC cable that's suppressing the electric fields, there's going to be a very high electric field around that wall. Always turn the power off, especially if you're using bed canopies too. Turn the power off, get rid of that electric field. There's less garbage to process out.
Thank you. Mike Mieki, I apologize again. Mieki Jacobs asks, I have a client who wants to use a grounding mat, but he has a Federal Pacific service panel, so can't shut off any breakers. Would it still be okay to use the Ncb in a home with this kind of panel?
As long as they have this fourth wire, an equipment grounding conductor that goes to the outlet and you can have access to it, yes.
Thank you, both of you. I skipped one here and I shouldn't have. Ruth Feldman asks, so I have a Samina grounding mat, was told not to use it by a building biologist due to dirty electricity. Would the Ncb solve this problem?
It will solve the dirty electricity problem, yes.
Thank you. And thank you, Ruth, for the question. Daniel asks if I'm not seeing any of my questions. Daniel, no, that's just how many questions we've been getting. Oh, okay. Lori, I see your question and Stephanie has reached out to you. I apologize for that issue. Anonymous asks, I believe that cords that come from certain vendors have a built-in resistor, can't recall the ohms. So what is the, I mean, he or she didn't actually ask the question, but I think the question that naturally comes from that is, what's the difference in functionality between a resistor that's incorporated into a grounding product and using a grounding product with the Ncb?
Yes, I was very excited to see that out on Amazon, and I know the website of who's selling it, and I think the doctor is fantastic. She's awesome, and she's going in the right direction. And the people that develop it have the absolute right intention. They recognize the problem, and the ohms on it is probably enough to do really good work. And in the video I saw her do, it actually was tangibly showing good results. One major fat problem though. My device maintains your protection with your breakers. Just a resistor will stop the breakers from being able to activate.
Is that the end of your answer, Andrew?
That's the simplest way I could put it.
Yeah,
Mine
no, that's fine. I
maintains
just
an
wanted to make
effective
sure.
ground fault path, so your breakers in your house will still work. Your GFCI will still work. With that other product, your GFCI will not work. Your breakers will not trip if there's a disaster problem. If your mat becomes live, if a live wire hits it, or a lamp cord energized, or whatever it is, if there's ever a disaster and you need to be protected, that other product will not enable those over current protection devices to protect you. Mine will.
Thank you. David Freund asks another question here, and this goes back to the multiple product per NCB potential use case. I understand why it may not work so well to daisy chain two grounding products if we touch each other to create the same circuit. But what if the products are completely separated?
Well, if they're plugged into one NCB and they come out, both your feet are touching the floor. So you both have a common reference point. So in general, it could work just fine. I can just imagine scenarios where there would be energy exchanged between these 2 points and allowed to circulate here, and it would never be the current that would go back to trip to breaker, but this would be enough to be harmful or be not beneficial to you, and you wouldn't be protected. Current would flow between you as a circuit. You would have current flowing here, and my NCB couldn't block that. So if you are completely isolated and you've checked it and you've got all the equipment, great, go for it. But we're talking about lay people here and how to set this up and to make sure that they're guaranteed to work right, or just ensure the best practices. So there are many, many scenarios. And if you're really good at this stuff, yes, you could probably set it up. But my recommendation is just keep this simple.
Thank you. And thank you, David. Bill Tyrell asks, is there an anticipated life expectancy for this product? And how would you know if it is no longer functioning properly? I'm just going to jump in real quick, and I'm going to paste in a link to an article on our site that explains how you can verify that the NCB is still functioning the way you would expect it to. But Andrew, can you speak to anticipated life expectancy, please?
No more than 100 years. Less than 100 years.
Yeah. And it's covered by, any product that I sell at SYB is covered by a lifetime warranty that we are very, very good about honoring. So, and we do have instructions, Bill, at that link. Hopefully you see it there in the chat pod.
And please watch those videos. I spent a lot of time making those, and I paid a lot of money paying an electrical engineer confirming everything I've claimed and said is true. And it's really fantastic. I'm very proud of what the NCB does. And that link right there shows the videos of what it's doing in action.
So thank you, Andrew, and thank you, Bill. Jane asks, and this is, if you could just repeat quickly, Andrew, she missed something in the sewing machine answer that you gave. How do you ground the sewing machine while you're working on it?
Basically, you have an alligator clip on one end, and the other end is basically sticks into the ground prong, and you can buy them on Less EMF, and I don't know if you carry them, but basically you want to clamp onto the metal frame of the sewing machine and ground it, not to the earth, but to an outlet that is the same outlet that the sewing machine is plugged into, because you need to have fault protection. Now, if it's a 3-prong sewing machine, it should already be grounded to the frame. And you can, test that with continuity and all those other kinds of stuff. But if it's only a 2-prong, you absolutely need to equipment ground it, safety ground it, not earth it. There's 250.4A5 says the earth is not an effective ground fault path. So you will not be protected by any breaker if you stick a ground rod outside in the earth.
Thank you. And thank you, Jane. Daniel asks, I take it directions for BBIs or experts comes with it or in the literature. Yes. So Daniel, again, the pro version is not yet out. That will have additional documentation, but right now we do have documentation for pro level users of the NCB, and we're continuing to add more, but you can see that at the link that I just pasted into the chat pod. So that's shieldyourbody.com/NCB. And there you will see several articles with documentation on advanced uses and product verification and so forth. And we are continuing to answer, to create more documentation as questions arise. And the
All
link
right, you
to,
don't,
yeah.
just go ahead and finish your thought. I'd love to
Oh,
jump in.
yeah.
Anytime.
And the link that I just pasted into the chat room is actually affixed to every unit of the NCB, Daniel. So it does literally come with the product, that link that I just sent. But Andrew, I guess you're probably going to point out that there's even more advanced documentation on your website, correct?
No, I was going to talk about Dave Stetzer and the cows.
Oh, so am I done answering this question?
Whenever you're done, I want to make sure before people start to leave the chat that they hear about Dave Stetzer's work.
Yeah. Go for it. I just clicked done. So yeah, go for it.
Very good. So.
Oh, do you want the screen share? You got
Yeah.
it. Good. Okay.
Okay. So one of the most important things that's happened is Dave Stetzer, Stetzer Electric, has done great work for dairy farmers. And you can see in this chart here are the volts over here. And you notice it's in peak to peak, and I'll talk later about what peak to peak versus RMS. But this is the voltage. This is basically, if you do the math, how much current would actually be thrown through a cow. But the blue is the milk production, and the red is the voltage. So if you track this line, the milk production is doing pretty good, but the voltage starts to come up and the milk production goes down. And while the voltage is up, the milk is low. It goes down, and finally the milk production starts to come back up, and it's rising. Oh, there's a hit, and the milk production goes down. And then boom, there's some high days. The milk production is really low. So you notice there's a direct correlation with the milk production. The cows weren't drinking enough water. They were getting shocked. They stopped. So this, if you go over here to the right side, what I want to get into here is volts peak to peak. So what we're talking about here is when we start to see bioactivity, I mean, anywhere here, let's just start right here. How many volts is this? 0.02 volts would be the equivalent of 20 millivolts. So 20 millivolts peak to peak is 10 volts above and 10 volts below, and you measure peak to peak would be 20. So just volts to one peak would be 10. Now, if you do the math, multiply 0.707, it becomes even less than that. So we're talking about anything less than 10 millivolts peak to peak. And in fact, the science that they came out with basically is dealing with RMS now. That's what a multibeamer would read, not an oscilloscope. 2 millivolts. If you are reading 2 millivolts on your body voltage meter, you're going to be causing a physiological response similar to what the cows were. And what they were finding is, this milk production here, and also we haven't even got into it very much, all the dirty electricity is showed with it, is causing very measurable changes. And if we're talking about a person standing at a sink and he's got his scope set up here between the sink and the floor, the bare feet on the floor, the hands touching the sink, and you're getting hit this way, maybe we can't tangibly set it up to measure milk production. But the cows have a very tangible thing that you can measure. But human beings need to start to understand that our resistance is very similar to cows, especially in wet conditions. It's around 500 ohms. If you have 2 millivolts, that's enough. So the whole standard has to change. Now, 2 millivolts is a voltage regulation. We're talking about current here. I want to go right to current because that's the final determinant of what is the actual harm. And we need to know, without the missing variable, voltage, resistance is the middle variable, and that's the skin, and then current. So if we're measuring voltage, we really don't know what the skin impedance is of how much we're really getting shocked with. We only know how much pressure is pushing on our body. But if we measure the current, we're done. We have all the variables taken care of, and that's why I'm coming out with the protocol for contact current protocol using the fluke, measuring the current directly and not voltage. Thank you.
Thank you. And there's some more questions here. We're coming up on 2 hours in a little bit here, which is our normal runtime, but let's see how motivated Andrew is to continue. Just a quick note before we get into some more questions. A reminder that this sale is through midnight tonight, Pacific time, which is in just about 8 hours from now. So if you're interested in the NCB, this is the best price that you're going to get it at for quite some time. Tomorrow, when I announce it to the list, I believe I'm offering 20% off. So this is 33% off with free shipping throughout the United States and Canada. Susan asks, would the NCB work on a Mac computer? I am sensitive and feel electricity flow. I guess maybe a better question, phrasing of that question for you, Andrew, is Susan feels she's sensitive and she feels the flow when she's working on her Mac. How would you recommend addressing that scenario?
Good. I'm going to give you an hour consult in about 25 seconds. Get a separate keyboard so your hands are not touching the laptop directly. USB plugged in, USB mouse, plug it in. So your now hands are separate and they're not going to be touching the Mac directly. Ground your Mac with a USB plug into an outlet. So the frame of it is grounded. Now the problem is the Ethernet cord. The Ethernet cord has a gigantic electric field coming into it. There's great products. Sean Cranish, ElectroHealth, has his products that he does. There's a couple of things you can use where you can actually ground and provide a pathway for the electric field from the Ethernet to the wall. But that's the whole thing, is ground that appliance to the wall. Don't use the NCB for your Mac powered in. Now, for some reason you have to, and you have to work on it when it's powered, you need the NFA 1000 sitting right in front of you to detect, does your electric field go up or does it go down? And then you adjust the dial in the NCB accordingly. So that's an advanced technique.
Thank you. Mark, that is done. Now, I see more questions have come in, but Stephanie curated some out of the chat pod. And I want to get to a couple of those. So are you, Jason asks, so are you saying that contact current is by another name the same as body voltage as measured with body voltage kits?
It's not, because body voltage is missing a variable, and that's resistance. It only measures the pressure on your skin. So body voltage kits just measure what's the comparison between point A and point B, and where you point A and where you put point B is the test. And that's why I said earlier with where you're going to put the black lead. It's very misleading, and I think it's very inaccurate way to actually assess. I'm going to give you the punchline. If you have to use a multimeter and a body voltage meter, if you're concerned with a ground mat, put the black lead on the mat and the red lead in your hand. So you're measuring just the voltage difference between the mat and your hand. You're going to see how much interchange, how much pressure is there pulling and pushing between these two things. And if it's higher than 2 millivolts, I think you're going to be in a problem. Now, if you use the black lead to the outlet, that same outlet that the grounding mat's on, remember, that's the two zeros matching themselves, and it's completely useless.
Thank you. It seems a couple of people asked a variation of this question. Most of the outlets in my house are not grounded, and I guess that an NCB would not be effective given this.
Yeah, you got to make sure that, get an electrician out there, open up the outlets and see if actually you have the old time BX and the metal plate that's actually grounded. So you may have a ground available in there, and you can actually get the electrician to put a grounded outlet in there, 3-prong, that's actually effectively grounded. So if it's really a 2-wire system and there's no ground in there, right, the NCB would not work. And it's code violation to actually put a 3-prong receptacle face on actually only 2 wires that are ungrounded. That's a code violation.
Kevin asks, will your NCB show millivolt reductions using a green wave broadband EMI plug-in dirty electricity meter on the same outlet?
Those only test the hot and the neutral. So they are not testing my meter.
The NCB.
Right. The
Right.
EMI is only testing the hot and the neutral. and mine is on the grounding system. So their device doesn't test the grounding system. So they will not catch what the NCB is reducing.
Okay, thank you.
Did I say ground and neutral? I said hot and the neutral.
You said hot and neutral.
Okay, good.
Yeah. Anonymous asks, and I have not fully read this question yet, so let's learn it together. I have relatives with a lot of physical problems. I have given them earthing products. However, I have felt worse using an earthing product there. I know earlier you indicated it would be better using an earthing product with an NCB. Did you mean, though, that it still might be doing them more harm than good to use the earthing product, even if it's with the NCB? I don't want to be making their health worse. And I know that's, that's a load. That question has a lot of complex assumptions that you don't know them. But what would your answer?
It's going to make it better. If you're using a grounding product, the NCB is going to make your situation better. Period.
Okay, thank you. Let's see. I'm scrolling back now. Gabriel asks, so connecting our grounding products directly with a ground rod cable from our window directly to the ground outside is safe, I suppose.
There is no such thing as safe. I need to, make sure that's very, very clear. There is a way to set things up that are safer or avoid certain scenarios. If you're attached to the earth outside, you're actually wide open for getting hit by a surge, either in, lightning or whatever it is. I mean, it's really not safe. You would need to have my pro version on that outside ground rod line. And we're not talking about that today. So it's really hard to use words like safe and healthy. It's like safer and more healthy.
Yeah.
And our whole world is trashed. So we're just trying to make things better.
Yeah, no, I totally agree. I mean, it's the same situation when it comes to the other types of EMF that SYB has been dealing with for a decade now. And we never say any of our products make anything safe. We always say they make them safer. Daniel also asks, so if there is a high bed map, I don't know if that's the right word. So if there's a high bed map, such as upwards of 30 to 80 volts per meter in areas, and the person can't control the breaker or unterminate wires, will the NCB be applicable still for grounding sheets, or would it require proper mitigation first, according to BBI practices?
Well, if you have the ability, always address your wiring problems. Always, as a rule. The NCB is not created to avoid addressing your problems. The NCB is, when we're done with everything else and we've done everything we possibly can and we still got a problem, that's when the NCB gets pulled out and we stick that sucker when we use it. I'm going to be an electrician soon. I've been doing electrical work for, 15 years. There are so many wiring problems. If you don't start with the wiring problems in your house, I would say that's criminal. If you're a building biologist and you're not starting with the wiring problems first, then you're not educated right.
Thank you. Okay, Dr. Harding asks, how does the filter work when contact current can be produced by frequencies in the air traveling through your body into the ground or foundation you are standing on?
Say that one more time.
How does the filter work when contact current can be produced by frequencies in the air traveling through your body into the ground or the foundation you are standing on?
Yes, it actually will work because I've measured many, many times. Remember, this is about a circuit. And let me go ahead and share a screen here because I'm just going to be drawing pictures and people are going to be going, what are you talking about? So we're talking about what is a circuit. And a circuit is a circle, just like I was saying before. Now, what's required for current to flow is a circuit. So what we're talking about here is an electron chain. So here's the source. And remember this, a lot of people have to change their mind. Electrons don't go to Earth. Electric fields don't go to Earth. AC electric fields don't go to Earth. Current doesn't go to Earth. That's false. That's incorrect. Goes back to source. What's the source? And in our system, we have a transformer, and that is our immediate source. And there's another source, and that's the substation, but we're not going to talk about that right now. So all the electrons and all of the current that you're talking about has a start and an end point, and that's the same place. That's the transformer. So it comes out on this bicycle chain. And now, if it has a path through the body, there has to be an in. So the in is the entry through, and then there's an exit. And if you have that, then you can have current if it finds a way through the floor or something grounded back to the source. If you have a circuit, you have current flow. My NCB blocks a part of that circuit. It takes a link out of this chain, and the chain no longer works. You have to have a successive touching of all the electrons pulling on each other all the way along. If that is broken, no current will go. I hope that answers the question. Are you there, or?
I apologize. I didn't come off mute. Yes, so I repeatedly thanked you for your answer and started reading the next question. So let me start that over. Anonymous asks, if you have 2 grounding pillowcases and 1 grounding mat on the mattress, you would need 3 NCBs, correct? And then there's a second part of the question. Well, why don't you answer that first, and then I'll get to the second one.
You could probably get pretty cool about it if your grounding mat was adequate to hit. Your 1 grounding mat was adequate to touch the 2 pillows. That would provide some sort of a very slow bleed or, pull away of the energy. But I would put an NFA 1000 on the bed and do all these tests. I'm just flying by the seat of my pants here, and I can't imagine the wiring problems or the power sources above, below, all this kind of stuff. So always, in my opinion, flying blind is a bad idea. You put that meter on there and you do what the meter says. If the electric field goes up, bad. If it goes down, good.
Thank you. And then the second part of Anonymous's question is, on the slide that said reduces electric fields, and so that's the electric field measurement measurement map that you did. Is it just better to not use the grounding mat at all?
This is a personal choice. Do you smoke? Do you like scotch?
I do actually like scotch.
I love scotch. So whether you ground or not is a very personal. I'm not telling you what religion or what brand to drink or buy. If you choose to, then this.
Mm-hmm. So if you are grounding, then so the point you're trying to make is you're not telling people to ground or not ground. You are saying if you are grounding with a grounding product, it'll be safer with the NCB.
Yes. Thank you.
Let's see. There's so many questions. It's hard to scan through them. And let me ask one more here. In the book Earthing, they mention that when we are grounded using a grounding or earthing device, the EMFs from computer screens, etc., actually flows around our body rather than being absorbed. Do you have a comment on that?
Yeah. Mike Holt, the premier electrician trainer in our country, has done some really good videos on some of the grounding myths. And I'd like you to be focused on his materials and not my claims. Mike Holt is recognized as the authority as far as electrical, whatever you want to call it, electrical principles, the National Electrical Code in our country. And he's got some, whoops, I missed the screen. Let me get back to it. And he's got some great videos about grounding myths. And I want you to see those. And what I'm going to do is I'm going to take this link right here and I'm going to put it in the chat. So this is a very, very controversial area. And with my heart as open as possible and care for the unborn, my wife and I we're not able to conceive, I believe, because of the shielding paint in the walls. The grounding principles, we tried grounding mats. We did all this stuff, and the grounding system, the current on the grounding systems made us sick. So I want you to not have to go through what I went through, and definitely grounding does not make you invincible. There are a lot of problems with grounding. So I want you to learn this from Mike Holt, and I will post his video link in the chat.
Excellent. Yeah, please do. Okay, everybody, we are now up at 2 hours. There are still lots of questions that we did not get to. In fact, the question pod has about as many unanswered questions as there were an hour and a half ago when, Andrew, you started answering questions. So for those of you who did not get your question answered, please email us at hello@shieldyourbody.com, and we will do our best to reply to you in a timely fashion. And a final reminder that this is the first time this product has been made available tonight in this webinar. And as a special offer to those of you who have taken the time to attend, there's a special 33% discount for the next 8 hours until midnight tonight Pacific time. So just visit shieldyourbody.com/ground. That's it's the link on your screen right now, shieldyourbody.com/ground. And then remember to enter ground 33 at checkout. Again, this is only for the United States and Canada at this time, because that's where the product is designed to work. So again, thank you everyone for taking the time to come out tonight. I really appreciate it. I really appreciate you making the time to learn Andrew's, what I believe is a very important message. I've learned a lot just by working with Andrew for the last 15 months. And I'm very proud to have some role in helping to bring this information to a broader audience. So Andrew, thank you as well for all your work on the NCB and learning all of this stuff and sharing it with the community. Thank you so much.
And thank you, R, for your mission to bring this to the light and your great audience that you have built up and trained and educated and helped. I imagine there are a lot of people in your audience that owe you so much, and I owe you a great debt. So thank you so much.
Thank you. So thank you, everyone. You will be getting an email tomorrow. It's automated. It will not have the recording of this. So the recording will be on our YouTube channel tomorrow. That's youtube.com/shieldyourbody. And the email will have a link to download an ebook. The ebook has a lot of the information that you've seen here tonight. So if you wanted just to keep a reference to explain this stuff with more links and so forth, just look out for that confirmation email tomorrow and make sure to download that ebook. So thank you, everyone. Andrew JG is asking that you were going to post a link to Mike Holt. I thought I saw you do that, didn't you? It's that YouTube.
One of them's the title, Grounding Safety Fundamentals, 1 hour and 13 minutes, 19 seconds. And then the link is all by itself. And I'm sorry, I did it too fast. I didn't put them together in the same one. At 6:03 is the link for the movie.
Okay, great. So again, everyone, thank you so much. And we'll see you again at the next webinar. Have a great evening.
Thank you. Yeah. I just posted, I think, correctly into the chat.